Good morning everyone. The topic I am going to talk about is low temperature storage systems, and the topic is calculation of refrigeration load in cold store. Introduction. It is necessary to select the capacity of refrigeration plant for the cold storage to maintain required storage temperature in the cold store. Under capacity plant, load may load to higher temperature of cold storage is required than while the capacity may lead to higher initial cost of the refrigeration system. The capacity of the refrigeration plant, it should be in such a way that it can take care of all the heat load of the cold storage. It is also necessary to reduce cold storage load in order to reduce the energy cost for the operation of refrigeration plant. The various factors contributing the total load of the cold storage are discussed. They are wall gain load, air change load, product load, miscellaneous loads, and total heat load. Wall gain load. The heat flow rate by conduction through the walls of ceiling and the floor of the cold storage from outside to inside is called wall gain load. The value of U, it depends on the materials used in construction and the insulation used in the constructing of wall as well as on the thickness of these materials. If either U or 1 to A, they are different for different walls, then it is necessary to calculate heat of each wall or ceiling or floor separately, taking corresponding values of U and 12A plus or minus T. The overall heat transfer coefficient, it is given by where HO is equal to convective heat transfer coefficient on the outer surface, HI is convective heat transfer coefficient of the inner surface, and X1, X2 is the thickness of different layers of wall, and K1, K2 are the thermal conductivities of different layers of wall including insulation. Air change load. This is the amount of heat carried by the air when cold storage door is opened and part of cold air is replaced by outside warmer air. The air change load depends on the number of air changes occurring in the cold storage, enthalpy of outside air and inside air. The measurement of amount of air change due to door opening is difficult, and hence air change factor is used to estimate the amount of air changed. Air change load QA is equal to m H0 minus H1, where m is mass of air entering kilogram, H0 it is enthalpy of outside air kilojoules per kg Kelvin of dry air, Hi it is the enthalpy of inside air kilojoules per kg Kelvin of dry air. Mass of air can be estimated by multiplying volume of cold storage with air change factor. The volume of air is converted into amount of dry air in the volume taking specific volume of outside air. Next, about product load. It is necessary to cool the product from initial temperature to a storage temperature. The amount of heat can be removed from the product to lower temperature of the product from initial temperature to storage temperature, which is called as product load. It is also necessary to estimate the heat load for cooling of packaging material along with the product, as specific heat of product and material is different. For example, plastic crates are to be cooled from room temperature to the storage temperature. For product load, it is calculated as QP is equal to MP into C1 into T1 minus T2, where MP is the mass flow rate of the product in the cold storage. C1 is specific heat of product, which is kilojoules per kg Kelvin. T1 and T2 are the initial and final temperatures of the cold storage. Similarly, heat load of packaging materials transferred in the cold store along with product, it is estimated as about taking the mass of packaging material with specific heat and temperature difference. This load is added in the actual product load. For frozen foods, QP is equal to MP into C1 into T1 plus TF plus MP into HFG plus MP into C2 into TF minus T2, where TF is freezing temperature, HFG is latent heat of freezing, heat product due to heat produced due to respiration of fruits and vegetables are required to be considered for such type of cold storages. QR is equal to MP into kilojoules per kg per H into respiration rate, which is kilojoules per kg. Then miscellaneous load. It consists of primarily of heat given off by light and electric motors present in the cold storage. Cooling load for electric appliances in terms of kilojoules is given by QC equals kilowatt into 3600 kilojoules per hour, where the heat load from occupants is calculated based on the data available for heat loss from the human body. It is necessary to refer standard data if heat loss from human body under the different temperature conditions. For example, a person at rest at 20 degrees Celsius, the total heat loss from the body is 400 kilojoules per hour. In this, it discusses about air change per hour for cold storage due to infiltration and door openings. For example, for 10 meter square, the air change is 1.23, and for 20 meter square, the air change is 1.95. Similarly, up to 1000 meter square, it is 0.10. Similarly, for each change in volume, the air changes. Total heat load is given by Qt is equal to Q of W plus QA plus QP plus QM. It is the common practice to add 10 to 15% of the total load as safety factor. After adding safety factor, the cooling load is multiplied by 24 hours and it is divided by the desired operating time in hours to find the capacity of the plant required for cold storage. What is a cold room? It is used for storing perishable goods such as meat and vegetables to slow down their deterioration and preserve them as fresh as possible. Heat accelerates their deterioration, so the product should be cooled down by removing the heat. To remove heat, we use refrigeration system as it allows accurate and automatic control of the temperature to preserve the goods for as long as possible. These are the cold room heat sources like transmission load, product load, internal load, equipment load, and infiltration heat load. And these are the problems which are required for cold storage. Thank you.